Hi, folks. I'm recording a video for Section 7.4. And Section 7.4 has to do with what's called Trig identities. And what we'd like to do here is manipulate different trig expressions in several different ways. And I'm going to use some identities from our textbook, Section 7.4. Notice these are broken up in a few different categories. First here is called quotient identities. For example, the tangent of theta is sine over cosine. Reciprocal identities, where cosecant is 1 over sine. Pythagorean identities, such as sine squared plus cosine squared equals 1. And then these even-odd identities that allow you to replace the sign of a negative angle with the sign of a positive angle. All right, so I'm going to keep these identities handy as we work on some of these examples. So let me come over to this first one. It says, complete the following equation. And they want me to take tan squared minus secant squared of an angle and figure out what is that equal to. Well, let me come over to my identities here and see if there's some kind of a match of an equation that involves both tangent squared and secant squared. Well, as I look over these identities, I'm noticing there is one identity right here that looks like it involves both the tangent squared and the secant squared. So let me write this over here. It's tangent squared plus 1 equals secant squared. Well, what I'd like to do is manipulate this to make it look like the left side of the equation I'm given here. So I want to get tan squared and secant squared on the same side of the equation. So let me subtract secant squared from both sides of this equation. Okay, if I do that, I'm going to end up with tan squared minus secant squared plus 1 equals, on the right-hand side, I have a secant squared minus secant squared, so that's 0. But one last step, because remember, I want to get the left side to match what they're giving me in this problem. So I want to get this tan squared theta minus secant squared theta by itself. To do that, let me subtract 1 from both sides of this equation. All right, well, now I have the answer I'm looking for, because now I have that tan squared minus secant squared theta equals -1. So I know my answer then should be -1. And again, the key of this problem was recognizing that this identity, this Pythagorean identity, was a match to the expression they gave me. All right, so my answer here is -1. Okay. All right, let's go to the next question. All right, this one is asking us to work out this expression involving cosines. All right, let me write this down here. It says cosine of negative theta subtract cosine of theta. All right, well, whenever I'm trying to simplify some of these trig equations, I'd like to usually eliminate negative angles. So let me come over here to my even-odd identities. And this identity right here says if you have cosine of a negative angle, it's really the same as the cosine of a positive angle. Let me give you an example here. If I was to ask you, what is the cosine of -30 degrees? Well, it turns out the answer is 1/2. But that's the same as cosine of, excuse me, this is the square root of 3 over 2. But that's the same as cosine of positive 30 degrees. So notice the way the cosine of -30 is the same as cosine 30. So that's why this identity makes sense, but that tells me that this cosine negative theta, I can just replace with cosine theta. That's what that even-odd identity tells me to do. But now I have a cosine theta minus cosine theta, and of course, that's just 0. So the answer to this question should be just 0. All right, let's go to the next one. So it says, which of the following is not an identity? So they're asking us to look at this list and try to identify which one of these is not true or not an identity. All right, let me go to the first answer. It says cotangent squared of theta plus 1 equals cosecant squared of theta. Is that true? Well, if I come over here to my listing, notice that is a valid Pythagorean identity. Here it is. So yeah, that's a valid identity. So that one is valid. Let me go to tan theta. It's giving me that tan theta is cosine over sine. Well, if I come over here, notice that's not a match. Tan theta is really sine over cosine. So they incorrectly have a fraction flipped upside down. So this one is a big no here. This one is no. Let me go to the third one. It says cosecant theta is 1 over sine. Well, here's cosecant equal 1 over sine. So that's valid. And then this last one says the tan of negative theta is equal to negative tan theta. Well, when I come over here to these even odd identities, yes, that matches. So that one is correct. So the only one of these that is not an identity is this tangent theta, second choice. So the second choice is the correct answer on this one. All right, let's go to this example. So this one is asking us rewrite cotangent theta times secant theta in terms of sines and cosines. So what they're really asking me to do is replace cotangent theta, replace secant theta with their equivalent expressions, but I should only end up with sines and cosines in my final answer. All right, well, I'm going to use these identities to help me out. All right, let me come over to cotangent theta. Now, I could either use this reciprocal identity or this reciprocal identity. But remember, I want my answer to be in terms of sine and cosine, so that's why I'm going to go with this one. So let me write this down here. We have cotan theta times secant theta. Well, cotan I'm going to replace with cosine theta over sine theta. All right, now let me go to secant theta. Well, here's an expression, a reciprocal identity that says secant theta is 1 over cosine. So I'm going to replace this with 1 over cosine. Now I'm going to try to simplify this expression. Notice I have a cosine theta on top and a cosine theta on the bottom. Those cancel out. So it looks like I'm left with just 1 over sine theta. And that's the final answer. My answer here is in terms of sines and cosines. Actually, it's just in terms of sine. So that is going to be my final answer. So I'm going to enter this in the answer box. I'm going to use a fraction. And I'm going to put 1 over. And I'm going to use sine of theta. And you might notice here's the angle theta available to us right down here on the bottom menu. So I'm going to type in sine of theta. All right, so in this example, we replaced the trig functions they gave us with their equivalent trig functions that were based on only the sine and cosine functions. All right, let's go to the next one. All right, this one's a little tricky. This one actually involves a little bit of algebra work. So let's take a look here. So they're asking me here, establish the identity. Now what that means is they want me to be able to show that if I simplify this equation, I end up with one of the identities that are on the right-hand side of my screen here. And they're going to guide me through what I should do here for this analysis. All right, well, it looks like they're telling me to multiply and write the left side expression as the difference of 2 squares. So what they're really asking me to do is take the left-hand side, which is cosecant theta minus 1, times cosecant theta plus 1. And they're really just asking me to multiply this using a FOIL kind of multiplication. So let me do that. I'm going to do a FOIL multiplication here. All right, well, cosecant times cosecant, that's cosecant squared. Cosecant times plus 1 is plus cosecant. Now let me take this -1 and let it multiply cosecant. That's going to be minus cosecant theta. And then I'm going to take this -1 times +1 in the back, which leaves me a -1. But notice these middle terms cancel out because I have a plus cosecant theta and a minus cosecant theta, so those cancel out. So I'm left now with just cosecant squared theta minus 1. And that's what they mean when they say the difference of two squares. This expression is the difference, because it's a subtraction, and it's two squared quantities. So this is the answer they're looking for in this box. Let me do it. So I'm going to enter cosecant, and I'm going to use this exponent notation here. So this icon lets me put an exponent. Cosecant, now I want to enter the angle theta and minus 1. All right, now they asked me, how do I know that this expression is equal to cotangent squared theta? What identity leads me to that conclusion? So really what we're ending up with here is cosecant squared theta minus 1 equals cotangent squared theta, right? Because remember, this left side we figured out was cosecant theta squared minus 1. Well, you might notice that if I was to add 1 to both sides of this equation, I would end up with cosecant squared theta equals cotangent squared theta plus 1. Well, that exactly matches a Pythagorean identity. So really the answer to this question is we know this is true based on this Pythagorean identity. All right, folks, let me do maybe one more example. And this example here is going to be a little similar in the sense that it's going to walk me through steps to verify this identity. Verify the identity means I'd like to be able to show that the left side is equal to the right side. All right, here's what it says. To verify the identity, start with the more complicated side and transform it to look like the other side. All right, so what they're asking me to do is rewrite this left side, and we want to be able to show that after simplifying, it really ends up just equaling cosine theta. And again, they're going to walk me through the steps on how to do that. All right, well, I'm noticing, let me click in this drop-down menu so we can see the choices. All right, so they're asking me to apply one of the identities from Section 7.4 here. All right, well, one thing I'm noticing here is they've set up this box to match the numerator of this fraction. Right? Everything else here is the same. It's just that the box is intended to represent sine squared theta. Well, let me come over here to a Pythagorean identity that involves sine squared theta. So I have this Pythagorean identity that says sine squared theta plus cosine squared theta equals 1. But I want to replace sine squared theta in that answer box. So let me get sine squared theta by itself. So I'm going to subtract cosine squared theta from both sides. Okay. If I do that, I'm ending up with sine squared theta equals 1 minus cosine squared theta. All right, well, that gives me the answer I should put in that answer box. It's going to be 1 minus cosine squared theta. So let's do it. 1 minus cosine squared theta. By the way, notice it says do not factor. So they don't want us to do any factoring yet. They just want us to enter the expression that we came up with based on the Pythagorean identity. So we just use Pythagorean identity. So I'm going to select that from the drop-down menu. All right, now it wants us to go one more step. It wants us to figure out, and here are my choices, what it wants me to do. It either wants me to factor the numerator, divide out a common factor, or apply a quotient identity? Well, I'm noticing that the numerator here is 1 minus cosine squared theta. But I remember from factoring that 1 minus cosine squared theta is the difference of two squares. So I can write this as 1 plus cosine theta times 1 minus cosine theta. So that's what I'm going to do. In this answer box, I'm going to replace this 1 minus cosine squared with this factored version of the difference of two squares. Okay? And then I know I'll be choosing factor the numerator because that's what we're going to do. All right, so let me do this as the difference of two squares. So it's 1 plus cosine theta and 1 minus cosine theta. All right, well, there's one last step. They're asking us to now show that this expression really simplifies to just plain old cosine theta. And let me click on this drop-down menu to see what my choices are. And I'm looking at my choices here. And let me go back to this expression, and maybe I'll be able to figure out a little bit of simplification that can be done here. So here's what I have at this step. Let me write this down here. I have 1 minus 1 plus cosine theta, 1 minus cosine theta, all over a denominator of 1 plus cosine theta. But what I'm noticing is I can cancel out this 1 plus cosine theta because it shows up top and bottom. Well, if I cancel that out, what I'm left is 1 minus, and then in parentheses, 1 minus cosine theta. Well, I'm going to distribute this negative sign inside the parenthesis. Then it's going to be 1 minus 1 plus cosine theta. But of course, 1 minus 1 is 0. So that's going to be 0 plus cosine theta. And you could see we end up with the final answer here, just cosine theta. So really, this was canceling out the common factor of 1 plus cosine theta that appeared on both the top and bottom. Okay, so we divided out the common factor and simplified to get the final answer here. All right, folks, hope this is helpful as you're working in the Section 7 for homework.